This next example, we want to find absolute max and absolute min again. And again, we're not given an interval. So if you're given an interval in WebAssign, life is good. You can just find the critical numbers in your first step by setting the derivative equal to 0, and then just compare them to your endpoints, and it's not too bad. But this one, we don't have an interval. So our second step, if you're missing one or more of your endpoints, you have to make a sign chart. So my first step of this would be to take the derivative and set it equal to 0. I'm noticing I have a quotient, but it will have x's in the top and in the bottom, so I don't have to use the quotient rule. You only have to use the quotient rule if there are x's in the top and in the bottom. So I'm going to take a second and just rewrite this as a negative exponent, so that I don't have to use the quotient rule. I think it's easier to use the chain rule. So it's 2, and then you have x minus 1, and since it's in the denominator, it's raised to the negative 1 power. So I'm going to use the chain rule on this instead of the quotient rule. Which means I'm going to bring down the power, so I'm going to keep that 2 and bring down the negative 1. 2 times negative 1 is going to make it negative 2. So you bring down the power, you keep the original inside, and raise it to your new power. Negative 1 minus 1 is negative 2. There's my first part of the chain rule. Bring down the power and keep the original to the new power. What's the last part of the chain rule? You want to multiply by the derivative of the inside. What's the derivative of 1x minus 1? Derivative of 1x is 1. Derivative of minus 1, that's a constant. It's 0. So I could just do 1 times negative 2. It's still going to stay negative 2. And I have x minus 1 to the negative 2. Multiplying that 1 at the end. There's my derivative, and my method for setting it equal to 0, I have to either factor, solve it like a linear equation by like adding or subtracting things and then dividing by the coefficient, like we did with that 2x equals 0, or if you have negative exponents, you need to put those where they belong. So what's our method for this one? Should we factor because there's an x squared? Should we move things because there's just a regular x? Or do we need to put negative exponents in the denominator? This one, we need to put negative exponents in the denominator. I'm going to keep the negative 2, but I'm going to put this x minus 1 squared in the denominator, where it belongs. Because it's a negative 2, it goes in the bottom. It's just a regular squared. Now I can set this equal to 0, and I want to think about what makes either the top 0 or the bottom 0. Well, the top is negative 2. Can any x value make that 0? No. Negative 2 is not worth negative 2. So I don't get a critical number from the numerator. That's fine. Can anything make the bottom equal 0? What makes x minus 1 equal 0? Add 1 to both sides. X is positive 1. If x was positive 1, we would divide by 0. So this makes f prime undefined. So my next step would be comparing this x equals 1 to my endpoints. This is actually not even a critical number because it doesn't go into the original, and that's just a detail of the critical number. It has to be in the domain, and this makes the original divide by 0, so I'd have it undefined, and I'd just be comparing endpoints. So that's something you can use in WebAssign. But for this one, I'm not given endpoints. I'm going to bring step 2 up here, and I'm going to make a sign chart because I don't have endpoints. I'm going to put my critical number on here where f prime is undefined, and that's at x is 1. I'm compare a number to the left. I usually like to plug in 0 whenever I can, and then compare a number to the right, and I could choose anything. Maybe I'll just be plugging in 2. So if we plug in 0 into the derivative, the numerator is always negative 2, so the top is always negative. The bottom, 0 minus 1, is negative 1, but negative 1 squared is positive. So at first, this function is a negative divided by positive. It's decreasing. Now I'm going to plug in 2. The numerator of my derivative is negative. The denominator is 2 minus 1, which is 1. 1 squared is going to stay 1. So I get a negative divided by positive again. It's negative. So again, you might not know what the graph of this looks like, and that is totally okay. You can plug it into Desmos.com and see what it looks like. If you want a visual, that's totally fine. But if something's always decreasing, let's draw a very easy example of something that's always decreasing. Let's just make it as simple as a line. It doesn't have any relative max or min, because there's no sign change and there's no absolute max or min unless you're on an interval. An interval would give us an absolute max and an absolute min, but this one isn't on an interval. It's looking at the whole picture. And if we look at the whole picture, it's going down as we go to the right, and it's going up as we go to the left. So there's no bounds. There's no absolute max. There's no absolute min. So this one's always decreasing. No absolute max or min. And I'll actually throw an extra video in here next if you want to see what happens with endpoints, just for the homework. So I'll use the same function with the same derivative and put some endpoints on it. So if you want to see that, you can. It'll just be outside of the notes.